Hello, it's Maya from Scala again, and welcome to the happiness track again. Okay, our next speaker told me before the talk that I cannot call her a multitasking hero because divisibility of the attention doesn't exist. Anyway, definitely I can call her the master of attention shifting because she is a leader of the Zielona Góra Java users group, co-organizer of the Greenfield conference, biking and tap dancing lover. Please meet Magda Stożek. Today she will be talking about how to test your code like a pro and how to maximize the benefits of using a library for property-based testing. You can ask your questions on chat and Magda will answer them after the presentation. Magda, the stage is yours.
All right. Thanks, Maya, for this nice introduction. It's an honor to be able to speak to you here as part of the Scala Love in the City conference about one of my favorite topics, property-based testing. But at first, when I met property-based testing, I wasn't impressed. It was, I think, my first months when I started being a Scala developer that I realized that in every project that I join, every Scala project, there's something called property-based testing. And at first I thought, it's just another Scala thing. So I will get to do the same things, but I will have to learn to do them the Scala way. But then when I actually learned what it's about, I thought, whoa, no. So now this is powerful. This really changes the game. And the reason why I thought that is because with property-based testing, you make the library work for you. So your job is to define some rules about your code, and the job of the library is to find the edge cases for you, is to find some bugs, is to find some holes or pieces missing from the way you understand your code. So my first thought was, it was awesome. But my second thought was, why hasn't everyone told me about it before? It's awesome. Everybody should use that, and you can easily use it outside of Scala, outside of the functional world even. So today, I would like to do just that. I would like to tell you that property-based testing exists and that it's awesome. And during those 30 minutes, I would like to show you what it's about, how it looks like in the code, what libraries you can choose. And in the second part of my presentation, even though I may sound like a salesperson now because it's so great, I will tell you about some of the ways how property-based testing is maybe not such a good fit and things you have to watch out for. So let's start. And the best way to start would be to start with an example. So let's pretend we have a sample. This is our sample business logic. Our job is to provide a method to calculate discounts for our customers. So this is how it looks like. Our method takes a customer. This is the customer case class. Every customer has a string. We know when they joined and we know their date of birth. And the method also takes the date of today. And it has to return the discount for this customer, coded as big decimal here. And the logic is we want to give no discount for a person who is within our program or organization less than 1 year. We want to give 10% discount for a person who is with us between 1 and 2 years, and over 2 years, 20% discount. It's big decimal, so it will be 0.2 big decimal. And for a special twist, so that it's not so simple, if it's the customer birthday today, let's give them a 30% discount just this one day. So how would we go about testing that? In a traditional way first. So opposed to property-based testing, we will call traditional tests example-based testing. So the way I would go about that is I would write a couple of test cases, for example, like that. So the first one here, we're saying that the discount calculator should return 10% discount for a 1-year member. So we're just creating the customer here. They have joined 1 year ago. They have some date of birth, but it doesn't matter because it's not their birthday today. We calculate the discount, so we invoke our business logic, and we verify the result that the discount is 10%. A very similar test case, we return 20% discount for a 2-year member. So again, a customer who joined 2 years ago. We verify their discount is 0.2. Next, we would like to test the birthday discount. So we've got a customer who joined 1 year ago, but it's actually their birthday today. If I count correctly, they just turned 41 today. So we want to give them 30% discount. This is nice and tested. So this way, we've got the happy path scenario covered by our tests. But of course, we know it's not enough. We want to test the edge cases. So what could it be? I guess I would prepare 2 such test cases to verify that for a new member, we return no discount. So we got a very fresh customer who has just joined. We verify that their discount is 0. And let's maybe think of an edge case that even if a person is with us for 3 years, so they joined 3 years ago, we only give them 20% discount, because we want to make sure that if a person is very long with us, we don't give them, for example, 100% discount if they're for 10 years with us, because we would go bankrupt. So these are my 2 edge cases. And I would say, okay, that's fine. I've got the happy path and I've got the edge cases covered. So I did a pretty good job at testing, commit, push, and move on with life, move on with a new feature. So how would it be different in property-based testing? What would it give us? So if we're talking about properties, for property-based testing, property is at the center. So what is it about? Property is some kind of a rule about your code, which is always true. So no matter what data you put as input to your method, the output data has to obey this rule. And it's your job in property-based testing to think of such properties, such rules. So in example-based tests, you have a concrete example, you've got your method, and you've got concrete output. And in property-based testing, you define some kind of a rule. And this rule doesn't have to define your method in 100%. It can be some kind of invariant, some kind of, putting your code in safe boundaries, so that no matter what crazy data you put in your method, the result is okay, is sane, it is within those safe boundaries. So let's see how it would look like in the code. Again, let's go back to our sample domain. And what properties could we think of here, which would hold true no matter what the customer and the local date that we put as parameters? For example, one such property would be that the result discount is never less than 0. And another property could be that no matter the input, the discount is never bigger than 30%. So as I mentioned, it's not fully covering our logic, but it is those safe boundaries. What could be other rules, other properties here? We could say, for example, that if we have 2 customers, then if one of them joined earlier in the past and the other one joined later in the past, then the discount for the older one would be bigger than those for the younger one. This is something that has to hold true for the customers within that relationship. And what property could we think of for the birthday? We could say again that for any 2 customers of which one of them has a birthday and the other one doesn't, the discount for the birthday one is bigger than the other one. So these 4 properties are a nice set of properties which we could apply to our code, write the test for it, and make the library verify that it is really true. So let's look at that in an example. But before we look at examples, a word about history. So opposed to many things in computer science which started in the 70s, and we are maybe reinventing it again, the property-based testing has started just over 20 years ago with the implementations in Haskell and Erlang. And since then, a lot of libraries were created in many different languages. However, not all of them are created equal. I said at the beginning that here is the library which does some of the work for you. You define the rule, the library finds the examples. So it matters which library you choose. And some of those libraries, some of them are pretty basic. Some of them are very advanced and will generate better data for you and will help you find your bugs better. So where is Scala here? In Scala, you may have heard in the context of property-based testing about ScalaCheck and ScalaTest. So are they alternatives? Not really. In Scala, the most popular property-based testing library is ScalaCheck. This is a very nice library for property-based tests only. And what about ScalaTest? ScalaTest is the general Scala library. So chances are you already have some Scala tests in your code, ScalaTest tests. And ScalaTest support a lot of different styles of tests, different kinds of tests, and also property-based tests. But for that, it just uses the ScalaCheck library inside. So your choice really is to verify, is to check whether you want to use the bare ScalaCheck or ScalaTest on top of it. Which one is better? This is a very difficult question. For me, ScalaCheck has very sensible, very good defaults and excellent output when your check fails. ScalaTest doesn't have it, but on the other hand, ScalaTest has this nice DSL, these nice matchers. So it makes your code read like a book, and I just love it. So I cannot resign from that. So myself, I tend to use ScalaTest and ScalaCheck inside, but the decision is yours. These libraries have been around for some time, but if you'd like to check for something new, there are new ones being created, and ScalaCheck has some problems, some tweaks you have to be aware of, and so on. And there have been efforts to create some more modern libraries. So maybe you'd like to keep an eye on the Hedgehog library or the property-based testing support in Zio. They are kind of, at least the Hedgehog is kind of early release for now, but I think it looks very promising. So I don't know, maybe the next instance of my presentation will be the Hedgehog because I like it. But for now, I'd like to show you my examples in ScalaTest. But everything that I will be talking about today can be easily applied in any of those libraries, or they can be applied in any library in any different language for property-based testing, because the ideas are the same. So let's look at the example that we have been waiting for so far. This is the example that the discount is never larger than 30%. So inside it just looks pretty ordinary. We calculate the discount and we verify it's not more than 30%. However, all the magic is here. It is this for all customer and local date. So what does it do? This is the way of telling QuickCheck that, dear QuickCheck, please generate for me, I don't know, 100 or 1,000 pairs of customer and local date. And for each of such pair, run my test for me and verify that my property holds true. And the library provides you random data, but it's actually much more than random. It's something that I like to call vicious randomness or nasty randomness, because the library will try to find for you input, which may be tricky. So here, these are complex types, but if we were working with simple types like strings, you would for sure get an empty string, a very long string, strings with various char sets, maybe Polish characters, maybe kanji, maybe non-printable characters, and so on. Likewise, for numbers, you could get very low numbers, the maximum numbers possible for such type, and so on and so on. So this is one of the things that the library can be excellent at, or it can be basic at. So how nasty is the input that it creates for you? And what happens if your test fails? Well, for example, you get an exception like that. And here, looking at the exception, you instantly know what the problem is. It's leap years. It's the nightmare of programmers. So actually I forgot that leap years exist, and my code throws an exception for February 29th. And this is the single thing where property-based testing shines at. It is not biased, because when we write code as programmers, we have a couple of examples in mind. We write the code with those examples in mind, and we write the tests with these examples in mind. But the library, it is not biased. It will generate all kinds of crazy data for you. And just like here, it may help you find some bugs in your code. So as my colleague once put it, this is a tool of eventual edge cases discovery. And I think it's great. So how do we get this data? It's in ScalaCheck, you get the generators. So out of the box, you will have generators for your basic types. So for example, for numbers, for lists, I don't know, UUIDs, all kinds of strings, and so on. And I encourage you to take a look at this gen class or object to see what helper methods you can get there. But sooner or later, it won't be enough for you, because your idea is to provide the perfect generator for your concrete domain. Because if your generator generates data which is not valid in terms of your domain, it doesn't give you any value. Because if your test fails, then so what? Your code didn't even have to account for it. So it's like a false positive. So what you want to do is you want to have generator for your domain specific case classes, which generate crazy data, weird data, but correct data. So that you know that when your test fails, it means that you have a bug in your code and not in your generator. So what do you do if you need something more than a generator out of the box? You combine the generators, and you combine and base on the other generators and so on to provide your perfect generator. And this is an example of such a generator for our domain. What we needed was a gen parameterized by our customer type. So it will usually look like for comprehension like that. So we need an instance of customer. And for the name, we are using a built-in alpha string generator. But for dates, we don't have the built-in generator, so we need a helper generator or a helper method here. And I have defined it just here. It returns a gen of a local date, so this is what I needed. It's a def where we provide the start of the range and the end of the range. Again, we use here the default built-in generators for numbers. So just converting our date ranges start and end to numbers by to epoch day. And then we map the result back to the local date. So this way we get a generator which will generate the dates from the start of the range to the end of the range. And this just gives you an idea of how your generator will look like. Also, it can be much more complicated than that. And this will make your tests better. Sometimes this is still not enough. So one of the important things are assumptions here. Because sometimes you need to specify the relationship between the generated data. So like here in this example, where we need the birthday discount to be the highest, we want to make sure that if we have two customers, then one of them has a birthday and the other one doesn't. And the way we would specify such a relationship is with this whenever here. So we say that out of all the generated pairs of data, only verify the property when this condition is met. So when it is not the birthday of the other customer, and only then check if it's true. One thing to be aware of here is generally you want to make this condition quite easily met. Because if you make it very hard, then either the library will give up and say, I cannot satisfy your condition, or it will generate 100 data and you think you have a very good test, but it will filter out 90 of them. So we only get 10 runs of your test. And in the world of property-based testing, this is not enough. So that's something to be careful about. So now that I have told you that property-based is awesome, then why isn't it the case that everyone uses that? Why do example-based tests still exist? Well, there are a couple of challenges, and I'd like to talk to you about some of them. The first one is that property-based testing makes you ask your difficult questions earlier. So usually in normal development, the way I go about it is when I have to write a new piece of code, I write a simple code, I write a simple test, then I write a more complicated code, more complicated tests, then I think about the edge cases and so on. And here, the first thing you have to ask is, what is my correct data? And these are questions like, how much, what is the biggest number a person can earn? Or what is the longest surname? Or what is the biggest amount a person can spend on cigarettes daily? And so on. So even before you write your first line of test, you have to go back to your product owner and talk about such things. So this is different, just. The second challenge is coming up with properties. And this is the biggest challenge, because now I have shown you some examples, but when you come back in Monday to your project, you might end up staring at a blank space and thinking, so what could be the properties? You cannot just repeat your implementation. You have to be creative there. Fortunately, smart people have created some lists for us, lists of patterns, which we can consult for an inspiration, really, to come up with properties. And I will show you a couple of them, but there are more. The first one is Oracle. So not in a company name, but as in a person who knows everything. If you have a reference implementation somewhere, you could use it to compare to your result of your method. So for example, in my experience, I used to have some reference implementation of financial calculations in a spreadsheet. And if you put some numbers in some cells, then the macros worked, and in other cells, you had the results. And my job was to provide the same kind of calculations, but somewhere else. And my property-based test created such test, made the macros work, and verified that it's correct. So if you have this kind of Oracle, you are a happy person, really. Another nice and smart way is to try to talk about what your code does. And here, if you hear anything that you can turn into a property. So for example, in case of lists, you can say that the output list has to, for every 2 number, the second one is bigger than the first one. If you talk about it, maybe to your colleague or you brainstorm together, you may find a great property. So in this example, you can check the pairwise order in terms of sorting, and so on. Another great thing is invariance. So as in the beginning, I said that our discount is not more than 30%, not less than 0%. This is the kind of safe boundaries that you often are able to think of. And symmetry is great if, for example, you have some code in your code base to write something to the database and then read it back and then compare if you have the same as at the beginning. This is a great property. Or for example, you serialize some code, some data, and then you deserialize it, or maybe you inverse the list and then you inverse it again. So these kinds of patterns are really helpful for coming up with properties. The next thing is non-determinism. It's random data after all. So it may be that it's fine and green on your computer, but then it will fail next week on the CA. So what do you do with that? Well, you cannot say this is flaky test and ignore it. You have to actually look what the generated data was, maybe take the seed of the generated data, write it down, and provide an example-based test for that so that you don't end up with regression. You have to fix the bug and provide a regression test for it. And the other challenge, the last challenge is documenting. So what I do when I see a new piece of code which I don't understand is I often go to the test class and check the first happy path scenario there. And it's all I need at that point. At that point, I'm not interested in some invariants, in some assumptions, in some boundaries. So this is where example-based tests are great for documenting what the code should do. And it's one of the reasons why example-based tests have to stay. So as we are nearing to the end of the presentation, I have already told you that property-based testing is great, but I have also told you that it takes a lot of work and creativity and that example-based tests have to stay. So I would like to leave you with two strategies that you can apply from my experience. The first one is that you start traditionally. When you have to write a new piece of code, start traditionally with example-based tests. So you write a simple test, a simple code, simple test, more difficult tests. You get to talk to your business people, you get to know your edge cases, and so on. And when you think you've got it right, only now start with properties. It will make you think about your code in a different way. It will make you question your knowledge of the requirements. And for sure, it will make you go back to your business person to ask them about the edge cases. And maybe it will find some bugs for you or some bugs in your understanding of the requirements. And only now you can say you did just everything you could to find the bugs in your code. Sometimes this is a very long journey, a very long loop, but a nice one, an exciting one. And the second strategy is provide the properties only for the key components in your system. Because if it's so difficult and creative, but don't worry, you will get better at it. But still, in order not to overwhelm you, just start from the key components in your system. And what are the key components? It can mean two things. One of them is the components which are very complicated. No one really knows what it does. It's some, I don't know, crazy financial calculations or generating some weird things. Write the properties for them to make sure you understand them and that they work correctly. And don't worry about the simple parts of your code, which are just simple. And the second meaning of key components is the components which are most important to your client. So if there's an error in this component, someone will lose money. Maybe your client will lose money, or maybe the end users of your client will lose money. So you know you have to do everything you can to make them as clear from bugs and edge cases and misconceptions as you possibly could. This is where property-based testing is a very good fit. So to sum up, property-based testing doesn't come for no cost. It will make you think harder. Maybe you will have to go for a walk if you are stuck with it. Maybe you will have to think of the properties early in the morning when you have your fresh mind. Maybe you will have to talk to your colleague, and maybe you will have to come up with the perfect property together. However, all this cost gives you a value which you don't get otherwise, because it makes the library work for you. Where it really shines is in finding edge cases and misconceptions about how you understand the requirements for your code. And the hard part is coming up with properties, but don't worry, it gets better with experience. And the balance. Every project is different, so I cannot say to you that I advise, for example, 40% of example-based tests and 60% of property-based tests in every project out there. Every project is different. It has some parts which are complicated, some parts which are crucial, some parts which are just simple adapters and you don't really care. But if you find this sweet spot, if you find the right balance between example-based tests and property-based tests, then you know that you have done everything you could to make your code free from the bugs that you know about or the edge cases you know about, and from the edge cases that you haven't ever dreamed of. And if you'd like to test, if you'd like to know more, I encourage you to take a look at the documentations, which are quite good and show you the features I couldn't show to you because of not enough time here, like, I don't know, arbitraries or shrinking, which is great. The third link is a great series of blog posts, which will help you think about properties and how to come up with them. The fourth link is this blog post with this list of patterns, which you should bookmark and consult every time you need to come up with a new property. And all examples from this presentation are in a GitHub repo under the last link. Thank you. This QR code here will lead you to a feedback form if you have any comments about the presentation. And if you have any questions, which I hope you do, I guess we'll take them to this spatial chat.